All right, example number 2. We are looking at a reaction between hydrogen gas and fluorine gas that forms 2 moles of hydrogen fluoride. We have to use our bond energies to calculate the heat of this reaction. In other words, we have to find the delta H using our bond energies. First thing that we have to do is write out our reaction. So H2 plus F2 forms HF, right? And this gives us a hint as to how we balance this equation. 2 moles of hydrogen fluoride, if I put a 2 here, that is a completely balanced reaction. My next step is to draw out these molecules. So H, that would be H2, plus F2 is 2 fluorines bonded to each other. And HF is H and F bonded through a single bond. And there are 2 of these. All right, now let's go ahead and take a look at how we find delta H. So delta H, like we looked at in the previous example, the sum of the energies of the bonds broken minus the sums of the energy of the bonds formed. The bonds broken always refers to your reactants because those are the bonds that have to be broken before the new bonds are formed in the products. So taking a look at the HH bonds, just like I did earlier, I'm going to use the same sort of format. The coefficient there is 1, so I'm going to write 1 mole times, there is 1 of those bonds, times the bond energy of HH, or the HH single bond, which is 432 kilojoules per mole. And that allows my moles to cancel out, plus the FF single bond. Now looking at that, the coefficient is again 1, and there is only 1 of those bonds multiplied by the bond energy of the FF single bond, which is 154 kilojoules per mole. The moles cancel it out, and that is the sum of the energies of the bonds broken, right? So we took a look at the HH bond being broken and the FF bond, both of those single bonds, those bonds are now broken. We've calculated the energy associated with that. Now we have to subtract the sum of the bonds formed. So there's only one product and only one type of bond, which is the HF single bond. So taking a look at the coefficient, 2 moles, because the coefficient is 2, times one of those bonds, times the bond energy of an HF single bond, which is 565 kilojoules per mole. Again, my moles will cancel. Now, when I find the energies, the total energy of the bonds broken, it comes out to be 432 plus 154, which is 586 kilojoules. And notice it's kilojoules because the moles have now canceled, minus 1130 kilojoules. And when I subtract these two numbers together, I will get the answer negative 544 kilojoules. So this is the delta H of the reaction. Hydrogen gas plus fluorine gas produces 2HF. Okay,